So vectors 3, really it's just an introduction of vectors. We're not doing anything high stakes. It says, given the standard unit vectors I and j, and I know that we haven't introduced I and j, guys, before. So I'm going to go ahead and write notes here, guys, in a two-dimensional motion. In two-dimensional motion, meaning we just have x and y, right? The I indicates horizontal motion, or horizontal direction, sorry. And the j represents vertical motion, or vertical direction. If we had 3 dimensions, this is a side note. I'm not sure if we're going to get to it or not, guys. If we had 3 dimensions, x, y, and z, then it would be I, j, and k. If we had 3 dimensions, but we don't have 3 dimensions. So at the moment, we just do 2 dimensionals. All right, so having said that, it says, give the standard unit vectors I and j, copy the vectors in order to create the resultant vector negative 3, 5. So I'm going to put C delta notes. I'm going to put fast forward. You'll see what I'm talking, or maybe I should just do it now. Should I just do it now? Okay, I'll just do it now. So fast forward like 10 seconds. So here we go. Maybe not this exact question, but something very similar to it. So let me show you how it's going to look. So it is something like, come on, buddy. Is it not working? There we go. Can you guys see this screen? Is it showing delta? So here it is. Here's 1. It's almost the exact same thing. Given the standard units I, where I is 1, 0. See, that's a vector in the x direction. J is a vector in the y direction. And if you look closely, which you probably can't see, let me zoom in. Zoom in, zoom in, zoom in, zoom in, zoom in, zoom in. All right, so I'm zooming in. Can you guys see now? Like super awesome. All right. If you look closely, do you guys see the letter I right there? What about the J? Do you see the J, how it's just right on the y-axis there? So those are what you call unit vector. Anytime you see the word unit, they're talking about it's elementary, unit circle, unit vectors. They're just one unit. So here we go. They want me to copy these vectors in order to create the resultant vector negative 4, 2. Well, if I want to get to negative 4, I have to have 4 of these, but in the opposite direction. See how that says 1? I need to go negative 4 to the left. So where it says negate I click on that. And now look, it's in the negative direction. And how many of those do I want? 4 of them. So I just go 1, here's 1. So 2, there's 2. And then I just come back to here, grab another one. There's 3. There's 4. And that was kind of fun. I like that. That was fun. Now, how many do I need for the y or for the j? I need 2 of those vectors. Of course, I have to negate it. I don't want it going up. I want it going down. So I click negate j. And there it is. And I want 2 of those. So I grab 2 of these and I go 1, 2. And there it is. And then they're going to make me answer a whole bunch of questions. Write negative 4, negative 2 in terms of I and j. So I is a movement in the x direction. J is a movement in the y direction. So right here in front of that I, I'm going to type the number negative 4. Control negative 4. And then right here where it says j, I'm going to type the number negative 2. So I'm going to go negative 2. And there it is. I push try, and then they're going to make me answer a whole bunch of others. Negative 4 times my I vector, my I unit vectors, that's going to give you a negative 4, 0. So, all right, negative 4 and 0. And then here, negative 2 times 0 times 1, so it's going to give me 0, negative 2. So I'm going to type in 0, negative 2. 0 and negative 2. I should connect the external keyboard to this. And there it is. And I'm going to try. It says to try, click, and then yes. And you can't see it, but it's correct. Oh, what? Did it not do it? Oh, I got to submit. Submit, submit. And there it is. I got my green check mark. What do you guys think? Was that pretty easy, guys? All right. So let me go back. Okay, so there it is. So that's what you're doing. You're going to create 3 vectors in the I direction, negate it, 5 vectors in the j direction. That's going to look like negative 3i plus 5j. And that's how you write it. This is called the linear term, by the way, because nothing's being squared. So example, this next example says express the vector -6, -3 in terms of the standard unit vectors I and j. So that just means to write that statement. So this is in the x direction, this is in the y direction. So you're going to write it -6i. And I actually like to say plus -3j, plus -3j. But if you want to write -6i minus 3j, that's perfectly fine. So or -6i minus 3j. And I know that delta or del t or however you guys want to pronounce it, I know they're not putting little hats on it. Let's try and get in the habits of putting hats. Maybe it was hard to put a little hat on the delta thing because they're vectors, so we want to dictate that. Unless your professor tells you otherwise. But if you open up a textbook, if you guys have a physics book, do you guys have a physics book at home lying around? Maybe from your parents or an old one. Yeah, open it up, go to vectors, find something that says cross product. So if you have a physics book, go to the cross product, go to the index or put cross product or dot product. And see how they're taking care of the I, J, and K? See if they're putting I's or see if they're putting hats or not. Whenever you get a chance, not right now, but yeah. All right, anyways, it says given vector u and given vector v, -4, 1, determine the value of 2v minus 4u. You're literally just going to do what we've been doing all this time, guys. So 2 times vector v. So vector v is this one, so -4, 1. And then, like I said, I like to say plus a -4 with vector u. Now, when you get to the university, guys, whoever your math professor is or physics professor is, if he or she tells you that no, this indicates magnitude and -4, you can't have a negative magnitude. If they tell you that, then say, okay, fine. And then instead of a plus, make it a minus. But, I like to say plus a negative because I think it's easier for me. And then what you're going to do is you're just going to add up the x components, guys. 2 times -4, so here it is, chevron. 2 times -4. Plus, let's see, -4 times 1. -4 times 1. That's going to go in the x. And in the y, do I have enough room? 2 times 1. 2 times 1 plus -4 times -1. I don't know if I'll be able to fit it in there, chevron. So my final answer is going to be, let's see, 2 times -4 is -8. -8 minus 4, 8, 9, 10, 11, 12. That's -12, comma. And 2 plus 4 is 6. There it is, guys. I don't see any mistakes. If I made a mistake, please let me know. 8, 9, 10, 11, 12. No, it looks good to me. Does that make sense, guys? Okay. All right, let's keep going. Example 4, the next example, it says vector u is 4, -4, and v is -1, -2. Find a linear combination. That just means, well, you'll see right now, of the vectors u and v that would result in the vector 1, -10. So when it says linear combination, guys, it just means some constant vector u, that's a u there, some constant vector u plus some constant vector v. Now, I know you guys are smart enough. You probably do not need to create a system. You can probably just look at it and figure it out. What I want my resultant vector to be bracket 1, -10. So if you look, I see a 4, I see a -1. The only way I can get the x component to be a 1 is if I go 4 minus 3. That's the only way. 4 minus 3 is 1. So I need to multiply vector v by 3. Do you guys see that? Don't worry, I'll show you another way. You know what? Let me show you the best way, because right now we're just doing it with logic. Let's show you the way by systems. Let's do systems. So this is AU. So AU means A times vector U, 4, -4, and then plus B times the V. The V is -1, -2. And remember, we're trying to equal 1, -10. Keep the x components the same. Look, I'm just going to distribute. So I have this 4a, -4a plus vector -1b and -2b. And all that still has to equal 1, -10. Keep the x components the same. That's a 4a, that's a -1b. -4a plus a negative 1b has to equal 1 from the resultant vector. Now I'm looking at the other one. Negative 4a plus a negative 2b has to equal negative 10. Look, guys, system of equations. If I add these, let me go ahead and put a giant parenthesis on them around this right here like that. Not add. If I subtract these, do you guys see how the a's would cancel out? The a's would cancel out because that would turn to a plus. This will turn to a plus. And that will turn to a plus because I'm subtracting, guys. Negative 1b plus 2b, that's just b, equals 1 plus 10. Oh, man. I feel like that's too much. I should have gotten 3. Where did I mess up? That sucks. I did mess up, but where? Sorry, guys. Okay, I see where I messed up. Do you guys see where I messed up? No? Possible bonus points if you guys see it. I see it. There's a negative that should not be negative. Yep. This one. Guys, 4a is positive, and look what I wrote. I wrote a negative. I blame you guys. No, guys, don't hate me. Okay, I shouldn't have said that. I apologize. I do not blame you guys. I promise I do not. I'm just, it was a joke. Yeah, it was a joke. I promise. So there it is. I just turned a negative to a positive. If I add them, the a's will cancel out. So just add them. So there's no need to put negative anywhere. Don't worry. We'll do another example in case I lost you guys. A's cancel out. Negative 1 minus 2, that's a negative 3b. 1 plus a negative 10, that's a negative 9. And look at that. I get b equals 3, which is what I should have gotten. If b equals 3, I can solve for a. I'm doing equation 1. 4a minus 1 times 3 equals 1. 4a minus 3 equals 1. 4a equals plus 3, 4. A equals 1. So what vector will work? So here, let me write it in blue so you guys can all see the vector. So this vector will work. 4 comma negative 4. Did we say minus? Yeah. Minus 3. And then negative 1 comma negative 2. That will definitely give us that 1 comma negative 10. So since they want a linear combination, the only vector is u minus 3v. U minus 3v. I know you're probably thinking, Chavez, that was way too much work when I could have just looked at it and noticed that I just needed a 3 in front of that. Yeah, you're right. 3 times 2 is negative 6. Negative 4 minus 6 is negative 10. Yeah. You're 100% right. You didn't need to do all that work for that. All right, next example, guys. It's the same thing, but this one's more complicated. Don't worry, we'll be done after this, and I'll show you some delta. It says, given vector u is 2, negative 2, and v is 5, negative 1, find a linear combination of vector u and v that would result in the vector negative 2, negative 6. So I'm doing the same thing, guys. They want this, a times u, 2 comma negative 2, plus, or it could be a negative, right? But I'm just going to write plus b times 5 comma negative 1. And when I do that, I want to get the resultant vector to be negative 2 comma negative 6. And I'm going to go back to red, guys, because I like the color red better. Or at least in writing, I like it better. All right, are we still okay? All right, we're alive. Here we go. I'm going to distribute. So I have chevron 2a comma negative 2a. And then distribute that b there. So plus 5b comma negative b. If you want to put a 1 in front of it, that's fine. And I need that to equal negative 2 comma negative 6. Make sure it's a chevron there. Get the x components together, guys. 2a plus 5b. That better equal negative 2. There's equation 1 right there. Here's equation 2. Negative 2a, oh look, they're nice again to me, plus a negative b, that equals negative 6. Again, this is my system. If I add them, the a's cancel out. 5b plus a negative b, that's 4b. Negative 2 plus a negative 6, that's a negative 8. Divide both sides by 4, you're going to get b equals negative 2. Now that you know that b is negative 2, guys, you can find a. So 2a plus 5 times negative 2, all that equals negative 2. And you're just going to write 2a minus, or I guess I'm going to write plus a negative 10 here, equals negative 2. And then add 10. Maybe that's not conventional that it says plus a negative 10. So 2a equals, add 10, 8. A equals 4. So what is my linear combination? Here it is. I'm going to write it right here in the corner. 4u plus a negative 2v. And I know maybe you don't like that it looks like that and you just want to say minus. That's fine. Does it work? Let's see. 4 times 2 is 8. Negative 2 times 5 is negative 10. 8 minus 10 is negative 2. Yeah, it works. Let's see if it works for the y. 4 times negative 2 is negative 4 times negative 2 is negative 8. Negative 2 times negative 1 is positive 2. 8, what did I say? Negative 8 plus 2, negative 6. Yeah, it works, guys. It works. All right, don't worry, we're almost done. Give me like another 45 seconds and we'll be done. So let me go ahead and turn my tablet into a laptop. I'm just going to go ahead and just do like 3 more subtopics of delta, I'm starting to calling it delta now. It's already become habit, miss. I'll try not to call it delta.
Break the habit.
All right. Let me turn mine. All right, guys, can you guys see delta? Okay, so we're done with that one here. Let's go to the next topic, rewrite vectors with standard units. I think that's gonna be, yeah, this is gonna be too easy for you guys. Express the vector 5, 3 in terms of the standard unit vectors I and j. You're literally just typing 5i plus 3j and submit. And there it is, correct. I wanna see one if I type a negative. So let's do another one, new problem. Okay, look at this. I want to see if it's going to work. So I'm going to go negative 1i. You don't even have to type the 1 if you don't want to. But I want to type I want to go plus, and I want to see if it takes it. Plus negative j. And let's see if it takes it. Yeah, it takes it, guys. So if you want, you don't even have to write it the way they have it. They have it like this. You can write the 1 in front, and you can write a plus with a negative j, and that's still fine. So that, you'll be fine with those. You'll do those in seconds. Combining scalar multiples of vectors graphically. Let's see what that is. Okay, so this one might be a little bit, but it won't take you too long. Let's see. Given vector u, and there's vector u, 4, negative 2, and vector v, negative 5, positive 6, determine the value satisfying 3u plus 2v. Click and drag dotted. Okay, I get it. So here's what you're going to do. So there's what you want you to do here on this graph. So you want 3 u's. So here's a u. So there's 1. There's 2. There's 3 right there. And what do they want me to add? 2 v's. So here's a v. So I'm going to add 2 v's. So how do you add vectors? You go to the arrowhead of the vector and connect that endpoint to that arrowhead. That's 1. That's 2. And that's it. Where does it terminate? It terminates, the resultant would have been from the origin to that arrowhead, 2, 6. So you just type 2 here, type 6 there, submit. And there it is. Can we do that, guys? All right, one last one. I want to do one that has something that has a minus. Okay, perfect. All right, see how that has a minus u? Remember how I taught you guys? I would always turn it into a positive and then add a negative. So Chavez, what are you talking about? That's what I'm talking about, guys. I would do this: 6v plus, and I put a little vector there, plus a negative u, like that. So what I would do is I would negate the u. So let me negate the u, guys. So there's my u. And then I'm just going to add 6v to it. So v, oh, do I got to actually put a u first? Okay, so here's my u. Here's my u. So there's my u now, and I'm going to put 6 of these. 1, 2, 3, 4, 5, 6. And then where does it end? It ends at 7 comma negative 1. So 7, negative 1. That's my vector. What do you guys think? Pretty easy? Okay, and then I think we got one more. Combining scalar multiples of vector. Let's see this one. Oh, that's too easy for you guys. That's what we just talked about. 2u, so let's do that. 2 times 1 is 2, and then I'm subtracting v. So 2 times 1 is 2, minus a negative 2, that's 4, so 4. And then 2 times 2 is 4, and I'm subtracting 2, so 4 minus 2 is 2. Submit. And there it is. Sorry, guys, if this 6v plus negative u bothers you. I know that I've been told, like, Chavez, erase it. It's bothering me. It's not even part of the problem. So let me go ahead and do that now before we start getting hate mail. All right, there it is. So I think it's pretty basic. I think we've covered everything. So let me come back to you guys.